Hello everyone. Today we'll see how to make Android multiplayer game. In this there will be two parts, app and server. So I have modules for each of them accordingly. Here I'll be using gRPC with protocol buffers for communication between app and server. So before going into the code, I'll quickly show you a demo. I'll restart the server. So now it says server started and it has given me IP address. On the emulator, I have my app running, and based on some name, it will give me score. I have entered QWERTY here. It says, hello QWERTY, your new ID is 5. And on server side, you can see it has intercepted get score call. So why gRPC? It is already built on top of HTTP. In gRPC, streaming is really easy. Say if you want to stream real-time data of other opponents in game, gRPC makes life easy. It also supports types and validations, and it is faster compared to JSON as we have strict type checking. So we'll dive into the code. First, I'll explain server module. So here server is running on my laptop. When you publish an app, server would be running on cloud, for example, on Google Cloud Platform. So let's see how this server is made. I have main class called tutorial server. In this, I'm using server builder for building server on specific port. I'm adding services and I'm intercepting some method calls using server header interceptor. So we'll see some basics of gRPC first. So there are 4 types of service methods: simple RPC, client-side streaming, and other types of streaming. In this demo, we'll see simple RPC. Client-side streaming is useful when you want to share data of your opponents in real time. Bidirectional streaming is when both server and client are streaming together. So gRPC makes this very easy. Here I have action service implementation. So we'll see protocol buffers first. In server src main proto, I have one directory called actions. In this, I have message structure. What will be sent as request and what I'll get as response. So as you can see, I have ID and name sent in as request, and I'll be sending back enum of OK, market closed. So this can be anything, server error, and I'll be sending a message. These are just message objects of request and response. The actual services has been defined in tutorial message. As you can see, we have tutorial action service for now, and there is one service method get score. So request comes in as get score request, and it returns get score response. As we saw in getscore.proto, we had these two messages defined. From these proto files, we generate Java classes. So we generate stubs, and using those stubs, we can call the functions that were defined in tutorial message. In app level gradle file, you can see I have defined proto-C compiler. So it will use this protocol buffers compiler to generate Java classes from .proto files, using which we can call the methods from our app. For server module, we need generated classes to implement the services. So in the main class, you can see I have added service called tutorial action service implementation on some port. So we'll see how this tutorial action service is actually implemented. So it extends tutorial action service GRPC dot action service base. So this base was generated from the proto files that we had already defined in SRC main proto. Here we can have actions, data streams, and models, which we'll see in depth when we actually see live example. Here what is happening, we are getting request and we have response observer. Some of you might have used RX Java and might be familiar with on next, on error, and on completed methods. Here what I'm doing is I'm taking first character modulus 6 and whatever integer value it is, I'm just sending it as ID, new ID. Here max player is defined as 6. So I'm taking request.getName and char at mod max player, entering this text as log. On next, I have to build a get score response and set the message. So in gRPC, we build responses and requests using builders. So here I have new builder dot set message dot set status code and then build. So on next, this response is sent, and once you have sent the response, you have to call on completed. So this is action service. Here you can override other methods if you need as per your requirements. But here, as you can see, I don't have any methods to override. As in .proto file, I just have one method and I have overridden that in this action service. So I have added service. I am intercepting this in server header interceptor. This is a really easy interceptor where it is just logging that it has intercepted some call and it starts the call. And finally, I have defined handshake timeout error. So if client internet connection is weak and it has not established connection even after 30 seconds, it will just drop out. And finally build. Then in try catch block, you start the server and print the IP address. So this was server module, very easy. So these proto files will be in server module and app module. In server module, we need proto files to implement the action service. And in app module, we need proto files to call the methods from the generated stubs. So in both the modules, stubs are generated from the proto files. We'll quickly see app module now. I have used Dagger as it makes injecting stubs really easy. I'll quickly go through Dagger modules. I have main application component where I'll inject in main activity. So first, when you generate files, you need to build a stub. So this is generated file tutorial action service blocking stub, and I'm generating new stub from this dot new blocking stub method. To build stub, you need something called as channel, which specifies the server address and server port. Here you can specify if you want to attach any server certificate that server might be using, and finally build it. Here via Dagger, I have a channel module, and this channel module generates a managed channel. As you can see, this is from gRPC library, and this is sent to stub module. Here this channel is used to generate a new stub, and here I am attaching metadata. Some servers might need something like session ID or something equivalent for encryption purposes. For now, I'm just attaching session ID, but actually in server use can see that session ID is not checked, but still I am attaching some metadata and it returns this stub. In main activity, you can see I have at inject stub. So I'm getting that stub which was created in stub module. And then I'm setting listener on score button. So as soon as score button is clicked, something happens on background thread. So what happens is we get response by calling blocking stub dot get score. Blocking stub was injected in the main activity just after on create is called. As you can see, I have dagger.builder.inject, and then based on response, I'll send a toast message. So before even sending request by doing dot get score, here you can actually check for internet connection and if the server is actually reachable. Otherwise, this will give error. But for now, I am sure that server is running as it is running on my laptop. So here status, if status code is okay, I'll just display the message which was sent by the server, and it was sent hello name, your new ID is the newly computed ID. Else it will give server error. So if you don't know Dagger properly, you can see videos by Twisted Equations. I'll put link to it in the description. Dagger is just a small part where we get stub injected into main activity. In utils, I just have some constants like server certificate. Now we'll talk about server certificate. In server module, I have these two files called server.crt and server.key. Here I have private RSA key and here I have normal.crt file. So when you are making server, you would cast this as files and you can use transport security and give this files as server certificate file and key file. Here I don't need any encryption, but for now I have commented it. So once you add these files while building channel, you will need the server certificate to actually call the functions from stub. Otherwise, you will get an encrypted error or something. So I'm using Anko Kotlin library to do to get the score on background thread. So I can just use do async and call blocking stuff.get score. So that was it. And I'll again refresh server. Let's see. Your new ID is 2. So we'll quickly recap what all I have done. So first thing is you'll need to define .proto file. Once you have defined your messages in proto files and you have defined services in say tutorial message.proto, you'll need protocol buffer for Java to generate data classes. These classes provide simple accessors. It will generate stub. In server module, you will need generated classes to implement the services. In app module, you will need classes to get stubs and actually call the methods. The gRPC stub classes are generated when you actually run proto compiler, which we have defined in gradle files. These stubs also come in two flavors, blocking stub and normal stub. So blocking stubs are synchronous, which means they ensure that RPC call invoked on it doesn't return until it returns a response or raises exception. So this can make UI thread slow and it will make UI unresponsive. So if you have asynchronous stubs option, you can use that. It is useful when you are going to do client-side streaming by stream observer callback object. On app module, we have channel build. While building channel, we pass server.crt. Once channel is set up, we get stub by calling dot new blocking stub and pass channel into it. From this stub, we can perform RPCs. Welcome back everyone. So now we'll see actual example. Here I have opened my game called Bingo. It's on Play Store and real service is running on Google Cloud Platform. I have two modules, app module and server module. Before going into the code, we'll see demo first as usual. So I have my server running and on the emulator I'll start the game. So I had already launched it. Here I can select my color and I'll host game. This is not actually intended for single player, but I have number of players as 1 for testing purpose. And I'll click ready. So what is happening is first you have to make 5 numbers in a row and you'll cancel out 1 letter. Like this you have to make 5 lines. And in a real game, the one who makes 5 lines first wins the game. I hope that you have got some idea as to how this game works so that it will be easier for you to understand how the proto files were made. Here I can click new round and it will take me to new round. So let's see proto files first so that you know what is sent as a request and what we get as a response. So in app and server module, I have proto files in src main and proto. If you don't have this folder, you can always right click on this and create new Android directory. So as I told you earlier, we'll have actions, data streams and models. Broadly, we can classify proto files into this. In models, we have object definitions. For example, player. So each player will have name, his ID, color, ready and win count. Another example is room. Each room will have its count, room name, room ID, what time limit is set, what is the max size, and if it is private room, what is the password. So if password exists, player will have to enter password. So in models, I have definitions of objects. In our actions, I have actual message objects as to what will be sent as request and what I'll get as response. So for example, when you host room, so in host room request, I'm sending room name. So because when you host a room, you'll need to send the time limit, max size, room name, if you want to set password and your own details, the player details. Here I could have also entered as player as member in request. So you could import player from models. So you would have to enter import model slash player dot proto. And instead of these three, you could have just done player space player is equal to 8 or something. But here I needed only 3 fields. So I have manually taken these 3 fields. And in response, I'm getting if room was created or if room name was taken or if password is invalid. And if it is correct, then I'll be sending room ID as a response. We'll see another example. Say you want to click grid cell. So as you saw, we had to click the grid cell. And what actually happens is uh, you send room ID where you are playing, you send player ID as to who actually clicked it and the cell number clicked. So in response, you'll get if you clicked it, then it's okay. Or if it was not your turn, so it was not player's turn. Or if room does not exist itself, say there is some internet issue. And this is very easy response. You get status code and status message. So like this, you'll have your own protofiles defined for your game. Say for x and 0, you would have click x and 0 grid where you'll have boolean if it is x or 0 instead of cell clicked. So for details of how to make protofiles, I'll be putting links in description so that you know what data types are available, how you can create a repeated list. For example, if you want to send a list, you need to add repeated here. So it will send an array list. So that link will have all the details of how to make protofiles. Now we'll see next part, that is after generating protofiles, how to define the services. In server, I will have two services, action service and streaming service. So streaming service was for room. So when you join, after joining, you subscribe to that stream and it streams you data like if new player has joined, then it will add a new player, or if he has clicked ready, it will mark this as green. So you would be subscribed to the room stream. Once you have entered the game, you leave the room stream and enter game stream. So you'll subscribe to game stream so that constantly if opponent has clicked 11, you'll get what he has actually clicked. So that's why I have two methods here, and these are helper methods. So we have get room events updates and get game event updates. Similarly in action, you can see in proto file, in bingo message.proto, I have many methods that you can call. So all these methods should be overridden in our service implementation. So you can see I have all the methods. I'll go through one method as an example. So like I showed you, click grid cell, we'll see how this was defined. So first we were getting user ID and player ID and what cell was clicked. So first this was room ID. So first it will check if that room actually exists. So if it does not exist, it will say room does not exist as status message. It will set status code as room not exist, and it will send in on next and on completed. That's it. So next, if room exists, then we'll see if cell clicked was -1. This was for some debugging purposes. So if it was -1, I have set as internal server error. Else if we'll see if the player who has clicked the circle has actually the move. So if it is not his turn, it will set status message as not your turn and it will reject his click. So like this, you have to check for validations according to your game and send the error messages and set the status code. Finally, if everything is okay, you actually click it, and after clicking, you'll change the current player. So as this was turn-based game, I am calling change current player. So after you accept that it was player's turn and the cell was clicked, you need to stream it to other players. So what you do here is you'll have something called as player list in each room. So in room object, I have a player list which contains player details like user ID, and when a player subscribes to a game stream, he'll get a user ID. So these two will link how we stream from our server. So now, as I told you, in each room we'll have player list, and from that player list we'll be sending updates. So here I have send room event updates. So I'll tell you overview of what you have to do. So say I have get cell clicked, then you will create a new stream service implementation. You just create a new implementation, new object, and then call get game stream updates. So what it will call is this method, get game event updates. So in this, according to your request, so this request will be built in your action service. I'll quickly search for, so I have one event here. Okay. So you can see in stream service, if it's if the request was set as .clear game, it would just call on completed because it wants to clear that subscription. Then it again validates if room actually exists. So if current room is not null, only then will it go for current room dot get game event subscription array list. So in each room we have this array list. We get that. We check if player is subscribing for first time here. If it is first time, then you uh, add that to the room player array list. If player had quit, then you would get uh, quit as request dot get click cell. In this, if I go to quit function, so you can see in quit, I am uh, iterating through this game event subscriptions, which I got from the room. So as I told you, in room I have players list. Likewise, I have room event subscription array list and game event subscription. So both these subscriptions will have player names, player user IDs with their corresponding subscription ID. So based on that, I'll be sending cell clicked as player quit code. I've defined player quit code as -2 and next round as -3 just for reference. So when I set cell clicked as player quit code, and then I call this on the stream service dot get game event updates. So it goes from here to stream service. It checks if this was first time, else it will add it. Then if has quit, it will broadcast that player quit. So in app, we'll have to handle that as going back to room activity or something equivalent. If there was no winner, then we'll actually append what was clicked based on request. So this was definition of game event updates. So on the overview, what you'll do is once a cell is clicked, you will create a new service. So I have here stream service. And then from this new object, you'll call game events, game event updates. And from here, it will just broadcast to all the clients that had subscribed to this streaming service. It is important that you don't call response dot on complete after you stream something. Otherwise, when you try to stream next time, you'll get some server error that uh, channel was already closed. Now we'll see in app module, I have game activity. So I'll explain game activity as an example. So in game activity, this is around 1,000 lines of code. We'll quickly see what happens on click so that we are on the same page. So on grid cell click. So if it checks locally that if it is actually your turn, this validation also happens on the server. So this is like double protection. So you don't have to worry about if it's not player's turn. So I'm calling click cell asynchronously and passing the value. This value is the actual cell number that the player has clicked. So what happens in click cell asynchronously? So I have do async function from Anko library. It makes life easy so that you don't have to define loaders everywhere. So once you click cell, I have this post delayed function so that on the client app, it shows that the cell has clicked and it is processing. But actually, this would usually not be visible unless user has very weak internet connection. So we'll ignore this for now. So what happens in do async? So we have this stub as usual injected using dagger, and we are calling dot click grid cell from this injected stub. So remember you have to do this on background thread. So I'm getting data, and after we get data, you call UI thread and start this closure. In this I have hide is equal to false. This is for UI purposes. You can ignore this and implement according to your app in your app. So if you get internal server error or if it was not your turn, you send that toast message from data.status message directly. As I told you before, you would check for internet connection. So I'm here checking for internet connection and checking if server is actually reachable. Because if server is down, you don't want app to crash, even if user has internet connection. So in else part, I have UI thread dot on network down. On network down will start splash activity where it again checks for network and it displays user if server is down or if user himself does not have internet connection. So since I had subscribed to game stream, I don't need to actually get look for response in detail because I will be having some receiver. I will be having local broadcast receiver. So here you can see I have game one value, different switch cases, what I'll run into. So in on pause and on resume, I have attached this as intent filter, the grid cell click action. So when you subscribe to game event updates and app, you will need to pass a stream observer. Now this is an important part. This was not covered in demo, so I'll go into detail. Here I have streaming service. And here you'll have to override on next, on error, and on completed. So whenever you get a game event update, you do game event is equal to value dot game event, and based on uh, the intent and whatever was passed, you call that receiver, put all the extras you have in that intent, and do local broadcast manager dot get instance and send broadcast. So main reason why we are doing send broadcast instead of updating UI here is if you do any UI changes in this on next function, that function will return instantly at that instance and nothing will work properly. So what you can do is create a receiver as I have created on top, and then using local broadcast manager broadcast that. So in receiver, in as an intent, I had set the required fields. So I'm extracting that in current player ID, cell clicked, and winner ID. So based on event code, I'll handle each case appropriately. For now, I'll show you what happens when we get cell clicked value in the receiver. So when cell is circled, as you saw, you get a pop sound. For now it is mute, but it will start this pop sound dot start. Then for grid cell, if the value clicked is equal to the value in this game grid cell list, then it will set it as true. So this is again game specific. Here I had game grid cell individually in everyone's local client. So this grid cell is not on server for individual clients. So server just has to take what value is clicked and broadcast to other players in the game. So even if I have the phone, I'll and I have pressed say 16, I'll get something in this receiver. It will iterate through my game grid cell list, check if that 16 is there, which obviously it would be there somewhere. It sets its clicked as true, sets the color, and it swaps with this adapter data. So I'm using this game grid recycler adapter to create this grid, and whenever I click on this, it will create this circle animation, and whenever I complete a row, it will strike it off. So you can see I have this receiver where I'm looking for cell clicked value. Then if row is completed, it will start some sound. If it is my turn, you'll get uh, this text here that it is your turn. I'm getting this turn from current player ID because each of this intents will give me current player ID. So if it is my ID, it is my turn. Also based on cell clicked, as we saw in server, we had defined 3-4 alternatives. That if cell clicked is -2, it is game quit. If it is -3, it is next round. So I can see if it is player quit value, it is 3 and it sends quit intent. So if it is player quit, the current player ID refers to the player ID which has quit. So this is hacky stuff that you can do. You can define your own constants. So this is a basic communication that happens. We have streaming service, action service. We have two modules, app module and server module. Now I'll go through some advanced concepts in server module. So main part is filters, where you actually check for encryption, you check for some session ID or metadata that has been attached to the stub, the channel. Here I have server header interceptor. It's a big file. This was mainly used to check for remote addresses and user ID. So the main thing we have to control is whenever a client loses connection and reconnects, you'll get a new remote address. So you need some way to link that remote address to the player ID. So whenever the player or the client connects to the server, you'll get a session ID. Here I'm getting a session ID method, uh, checking for session ID. If it is add player, then there won't be player ID. In this case, we need to skip validation of player ID. And there are some other things like if session ID is null, it will say it is unauthenticated and description is session ID is empty. If it is reconnect method, it will start new call. If session ID already exists, for example, player is in game and he loses connection and then he again reconnects. So what happens is the client side will be unsubscribing from the game stream and again resubscribing. So we'll have two separate session IDs. So we have to remove the old session ID from that list, and that list is in the connection data. So in Bingo server, I have this connection data list. This has all the data about all the clients connected to the server. Back to header interceptor, I have this remove session ID from the list. So you can have two types, remove room streaming subscription and game streaming subscription. So you remove accordingly. Next we'll see termination filter. Here you force quit players if they're not responsive. So in action service implementation, I have a timer, local timer on server, that if player does not respond in say 60 seconds, this termination filter will force quit that player. We'll see from where this is called. It's called from Bingo Action Service itself. So I have termination filter dot force quit player. In stream termination tracer, I have tracer methods. So it will just log what method name was called. One more thing in server header interceptor, if you want to check uh, that get rooms method was called or add player method was called, you have to check for full name. And how you define full name is package name dot bingo action service slash the method name. So that is important part, package name, and then you have to do slash method name to actually check what method name was called. So while doing equals, you need to add that. In utils, I just have simple utils to convert enums to values to get exact values. I'll be putting link to the demo code in the description. It is on GitHub. This is on Play Store and you can play. If you like it, you can rate it. This is private on GitHub, but if I get enough requests, I would make it public. This has a lot of work, so I have ads in it. So if you like it, comment below and I'll make this public. The only thing in demo is it does not have streaming part, but I think I have gone in detail in this actual example as to how we can create a stream observer, override on next, and implement what all we have to do. So as a recap, I have created my own .proto files. From those proto files, I have used proto C compiler to get Java generated classes. On app, I am using those classes to get stub. To create stub, I need a channel. And to create channel, I will be adding server certificate. Let's see that quickly. So in channel, I'm adding this server certificate. So from those stubs, I'll call methods like clickcell or hostroom or quit game. Then in server module, you'll be overriding your action service and stream service if you have to handle that method appropriately. That's all for this video. I hope you learned something. If you have any doubts, you can refer to the repo that I have linked in the description. The demo repo that has simple RPC, how to set up server, how to add server certificate, and how to create channels and stubs in app. And then finally call methods using do async on a separate thread. Thanks a lot. See you next time.